this lesson, we're going to be talking about how to order and compare rational numbers. Now, we already talked about what a rational number is. It's a number that can be made by dividing two integers. So basically, it's a fraction. And it comes from the word ratio. And you can actually see the word ratio in the word rational. Now, a key thing to know when ordering and comparing rational numbers is that you always want to transfer all numbers into decimal form. So that means if you have a fraction or a percentage, you want to transfer that into a decimal. Let's go ahead and practice that with the 4 problems below. The first question says 82%. Now, 82% is a rational number, and we want to transfer this into decimal form. So we're going to look at the number, and we're going to look to see if there is a decimal within the number, which in our case there isn't. If there isn't, that means that we're going to place the decimal at the very end of the number, so right between the last number and the percentage. That's where the decimal technically is at this time. Then we're going to move the decimal 2 spaces to the left. So 1, 2. That's the new location of the decimal. So the new number here is going to be 0.82 or 82 hundredths. And you can also put a 0 in front or to the left of the decimal if you like. But there we just transferred 82% into decimal form. Let's try the next one. 4.5%. You can see here that this percentage actually has a decimal. So that's where we're going to start moving our decimal to the left. So we're going to move it over 2 spaces, 1, 2, and that's going to be the new location of the decimal. And when we do that, we can see that we have this empty space here in front of the 4. We're going to go ahead and put a 0 there. That's called a placeholder. And that's going to be our decimal, 0.045 or 45 thousandths. So basically what these two questions are saying is that these numbers are, they're the same number, 82% and 82 hundredths. They mean the same thing. They're the same exact number, just written in a different form. Now let's go ahead and look at a fraction. Let's go ahead and transfer this fraction 2 fifths into a decimal form. In order to do that, we have to do a little bit of long division. So we have to remember those skills from the years past. So let's go ahead and divide 2 divided by 5. The top number always goes inside the house. Okay, we're going to ask ourselves, how many times does 5 go into 2? And 5 does not go into 2. So that means that we have to add a decimal, and I'm going to raise it up to the top, and I'm going to add a 0. So now we can ask ourselves, how many times does 5 go into 20? Well, it goes in 4 times. So we're going to write 4 up above. And then we're going to say 4 times 5 equals 20. So I'm going to bring a 20 down here, and I'm always going to subtract it, giving me a remainder of 0. So the decimal that corresponds to the fraction 2 fifths is going to be 0.4 or 4 tenths. Let's try one more. 3/8. All right, 3/8. We're going to do 3 divided by 8. So let's go ahead and write 3 divided by 8. We ask ourselves, how many times does 8 go into 3? Well, it doesn't. So that means we need to add a decimal, and I'm going to raise it up to the roof, and I'm going to add a 0. And we ask ourselves, how many times does 8 go into 30? And the answer is 3. So we're going to place a 3 up at the top. 3 times 8 is 24. So we're going to write 24, and we're going to subtract them. 30 minus 24 gives us 6. Then we ask ourselves, well, since that's not a remainder of 0, we have to keep going. 8 goes into 6 0 times. So that means we have to bring a 0, and we have to bring it down, and we have to write a 0 here. So now we can ask ourselves, how many times does 8 go into 60? And the answer there is 7. 7 times 8 is 56. Let's go ahead and subtract them. The goal is to get a remainder of 0. 60 minus 56 is equal to 4, which is not a remainder of 0. So that means we have to continue to drop down a 0. 8 goes into 40 5 times. And 5 times 8 is 40. And you can see this time we're actually going to have a remainder of 0. So that means that our final answer is going to be 0.375 or 375 thousandths. So that's just another way to write the irrational number 3/8. So you can see with all of these problems here, we put each of these into its decimal form, which is exactly what we wanted. That is going to be the goal of today's lesson, is to transfer the numbers into decimal form. Now let's talk about how do we compare them once they're in decimal form. Let's go to the next slide. So what we're going to do is we're going to compare the numbers based on their place value. So in these examples, it says circle the largest number in each grouping. So let me show you what I mean by place value. Let's look at this first example to the left. You can see that I have 4 numbers, and all 4 numbers are already in their decimal form. So what I want to do is kind of treat it as if it were money. Or another way to say it is when you have a number that has kind of like a blank space next to it, go ahead and fill those areas in with placeholders of 0. So you can see, I'm going to go ahead and do that on the second one. I'm going to go ahead and put a 0 and a 0 so that both of those top 2 numbers are going out to the thousandths place. In the third number, I'm just going to have 1 0. And then in the fourth number, I'm already going out to the thousandths place, so I'm just going to leave it as is. So now that you have all of those numbers there, here is what we're going to use to compare. Let's go ahead and look at just the first number. So I could actually just say this number as 612. I'm going to compare that number to the number 600. And obviously 612 is larger than 600. So technically I could cross off this second example because I know it's not the largest number. Now let's look at the third number, 620. Well, 620 is much larger than 612. So I could actually cancel out that first one. Now let's look at the last 2. I'm comparing 620 versus 601, which obviously 620 is going to be our largest answer. So let's go ahead and circle that answer. This is the largest number that we have. Let's try another example. Let's look at the second one. So you can see that I have all of my numbers in decimal form already. So they may have been in fraction or percent form, but we transferred them into decimal. Now let's go ahead and fill out our placeholders. I'm going to go ahead and put a 0 in the first one to take it out to the thousandths place. The second number is fine because it's already to the thousandths place. The third number, I'll put a 0 placeholder. And the last number, I'll go ahead and put 2 placeholders there. Now let's go ahead and compare the numbers. Here I have 270. And the second one, I have 271. So between those 2 numbers, I can see that 271 is bigger than 270. So the first number I can actually cancel out. Let's compare 271 to the third number, 260. Well, 271 is larger than 260, so let's go ahead and cancel that out. Now the last one is just 200. So 271 is obviously much larger than 200. So our largest number here is 0.271 or 271 thousandths. All right, let's try another one. Let's go ahead and put in our placeholders. I'm going to put in 1, 2. I'm going to put in 1 in the second one, and then I'll put in 1 in the third or in the fourth one. Now let's go ahead and compare them. The first number is 800. Let's go ahead and compare that to 870. Obviously 870 is larger, so I'm going to cancel out the first one. Now let's compare the third one. So 801 and 870. Well, of course, 870 is larger. Now let's compare the second and the fourth. 870 versus 890. Obviously, 890 is the largest number. And that's how you use place value to compare your numbers once they're in decimal form. Now, let's try a challenging one. Let's try one that has negative numbers. So let's go ahead and first put in our place values. So I'm going to go ahead and put 0, 0. I'm just going to put 1 in the second one, and then I'll put 1 in the fourth one. All right, this one is a little bit more challenging, and you got to do a little bit deeper thinking here. So again, we're looking for the largest number. So what that means is, let's first go ahead and look at the digits. So the first one is 400. And then I'm going to go ahead and underline all of them. Now, there is a little trick in this one. Let's go ahead and talk about it. Now, as we look at these numbers, we can see that we have 400, 460, 423, and 490. Now, you might be thinking, well, 490 is the largest of those four numbers. But there's one extra piece we have to think about for this one. And what it is it's the negative out front. Think about the number line. When you have a negative number, you're actually moving in the left direction versus the right direction. So what that means is we're actually trying to identify the number that is closest to 0. So it's actually going to be flip-flopped. In this case, we're looking for the number closest to 0, which is going to be the number that looks the smallest. And in our case, it's going to be the top number, which is negative 0.4, or the 400 would be the largest because it's the closest to 0 when you're talking about integers. I know that one's a little tricky, but you kind of have to think backwards when you're working with the negative numbers. So that shows you how to compare decimals or rational numbers in decimal form. Now let's go ahead and apply these skills in some practical problems. Let's go ahead and look at this first problem. And I also have a little tool to teach you in this first problem. Now, just as a reminder, I do ask that you don't use a calculator for these problems. And I want you to try to use mental math the best that you can. Okay, circle the answer that could be placed in the blank to make the statement true. And we have 2/3 is less than a number, which is less than 0.77. So what we need to first do is figure out what these two numbers are. Obviously, we already know that 0.77 is already in decimal form. But let's go ahead and figure out what 2/3 is. And I'm just going to go ahead off to the side here and divide 2 divided by 3. And I'm just going to do a little bit of arithmetic to figure that out. So I know that 3 does not go into 2, so I'm going to go ahead and add my decimal and a 0. And I know that if I were to take 20 divided by 3, that's going to leave me with 6. So 6 times 3 is 18, and I'll subtract. I'm going to get 2, and you can actually see here that I'm going to actually continue this process. So I'm actually done at this point. This number is going to be 0.66 repeated. So really, I'm trying to figure out a number that is going to be between 0.66 repeated and 0.77. So let's go ahead and figure out which one of these, A, B, C, or D, fits that. Now, I have this little tool here off to the side. And this is just a little tool to help you with problems like this, just to kind of organize your work. So I'm going to go ahead and write each of these numbers in the boxes to the right. So I'm going to go ahead and write 77.5%. I'm going to write 0.32. I'm going to write 3/5. And I'm going to write 0.681. Okay, so those are the original form of the numbers. Now, let's go ahead and put those numbers into decimal form. And we might have to do a little bit of work for some of these. For the first one, I'm going to go ahead and I'll go ahead and do the work over underneath the number. So to change a percentage into a decimal, I have to move it over twice. So 1, 2. So that's going to leave me with 0.775. So I'm going to go ahead and write that in the second box. So 0.775. The second one is already in decimal form, so I'm just going to go ahead and leave it there. The third one, I have to do a little bit of work. I have to go ahead and divide 3 divided by 5. So I'm going to go ahead and put my decimal in with my 0. And I know that it's going to go in 6 times. And it is going to go in evenly to give me a remainder of 0. So that's just going to be 0.6. And then my last one, oh, I love it when they're in decimal form. It's just already there. So I'm going to leave it as is. And you might be wondering, well, why isn't she writing the 0 in the front? Again, you don't have to write that 0 to the left of the decimal, but if you want to, go for it. Okay, now that we have our decimal form, we can actually figure this problem out at this point. So let's go ahead and talk about, well, which one is going to be between 0.66 repeated and 0.77. Well, let's look at the first one. 0.775. Well, 0.775, if I were to compare that, it's actually going to be bigger than that 0.77, just by a little bit if you were to use that place value technique. So that is not going to be our answer choice. What about the second one, 0.32? Well, 0.32 seems to be less than 0.66 if we were to be using that place value technique. So again, that's not going to work either. How about 0.6? Well, again, using the place value technique, 0.6 is less than 0.66. So it can't be bigger. It's not going to work. Now, the last one, 0.681. Now, think about it. If I'm going to use that number here, I'll even show you the place value. So here's that number, and then here's the number that it needs to be greater than. And I'm going to go ahead and add a place value number. You can see that that top one is, in fact, larger than that second one. So that's going to be our answer choice. So our answer choice will be option D. It's the only number that's going to fit into that blank. Now you can see that we had to do quite a bit of work for this problem. Lots of different skills that you have to know in order to find, or in order to compare these rational numbers. Let's do a couple more examples. Circle the answer that correctly lists the numbers in descending order. Descending order means that's going to be the greatest to the least. So I'll go ahead and write that out here, greatest to the least. So let's go ahead and use our little tool. Now, if you look closely at the answer choices A, B, C, and D, you can see that they're the same numbers, just the same 4 numbers, just jumbled up. So go ahead and just pick one to work with, and let's kind of work from there. So I'm just going to look at option A, and I'm going to write those numbers in. So I have 1.5%. I have 1/5. I have 1.5. And I have 1/15. Now, with the second column, let's go ahead and put them all into their decimal form. And you can do the work right underneath the problem here. So 1.5%, I'm going to move 2 spaces to the left and put my placeholder in. That's going to leave me with 0.015. So that's going to be my decimal for this first one, 0.015. 1/5. Well, 1/5, we have to do a little bit of work here. So 1 divided by 5. I'm going to go ahead and add my decimal and my 0. And 5 goes into 10 twice, and it actually goes in equally with a remainder of 0. So that's just going to be 0.2. 1.5. Oh, I love these. I love when they're already in decimal form. So I'm going to write 1.5. And then my last one, I have to do 1 divided by 15. Now, this one's a little bit harder. So let's go ahead and look at this one. So we can see that 15 does not go into 1. So let's go ahead and take it. What I'm going to do here, let me show you. I'm going to place a decimal just like I normally would with a 0. But I can see 15 does not go into 10, so I'm actually going to place a 0 here. And 0 times 15 is going to be 0. And I'm going to go ahead and subtract them, leaving me with 10. And I'm going to go ahead and carry down a 0. 15 goes into 100 6 times. So I'm going to go ahead and write a 6. And 6 times 15 is going to be 90. So I'm going to go ahead and subtract them, leaving me with 10. And you can see here that this process is just going to continue. So I'm going to go ahead and carry down another 0. And you can see that 15 goes into 100 again 6 times. And I can continue this process as long as I would like. But I'm going to go ahead and stop there. And I'm just going to say that my decimal here is 0.066. Okay, this is where the place value idea is going to come in. So I'm going to go ahead and change my color, and I'm going to go ahead and fill in my place values. So there we go. And now I'm going to compare the numbers here. Obviously, with this problem, you can see that I have one number here that has a whole number, which is the third one. You can see that I have this whole number 1. That has to be the greatest number. So I'm going to go ahead and put a little number 1 next to this one, meaning that is going to be the greatest number. Now let's look at the other 3 numbers. Let's go ahead and compare their place values. So here I have 0.15 and I have 200. So I have basically 15 and 200. And obviously 200 is larger. But let's go ahead and look at the third one as well. Here I have 66. So you can kind of see which out of those 3, the largest is going to be the second one, 200, followed by the 66, and then followed by the 1.5%. So looking at the answer choices off to the left, if I were to rank these 1, 2, 3, 4, the one that it's going to match up with is going to be letter B. Now, another thing that you might want to do just to, be sure that you're correct is just rewrite them out in their original form. So I'm going to go ahead and write out. So number 1 would be 1.5. Number 2 would be 1/5. Number 3 would be 1/15. And then number 4 would be 1.5. So you're looking for the answer choice that matches that up, which is obviously B. Obviously, you can see here a very involved problem, but using this little tool might be helpful to you. All right, I've got 2 more problems for you. Put the following numbers in ascending order. Place the numbers in order using the empty boxes. Okay, so ascending order, that means it's going to be from least to greatest this time. So you have to be real careful with those directions. Now let's go ahead and write our numbers in our box here. So we have 1/20, we have 0.120, we have 120%, and we have 1.20%. And let's go ahead and take those numbers and put them into decimal form. So let's do the first one, 1 divided by 20. So here we go, 1 divided by 20. We have to do a little bit of work here. I'm going to go ahead and add my 0. And 20 doesn't go into 10, so I'm just going to go ahead and subtract them and bring down my 0, and it's going to be a 5. Leaving me with a remainder of 0. So there's my decimal. So we have 0.05. 0.120, well, that's already in decimal form. That's awesome. Let's keep it that way. 120%, let's go ahead and transfer him. We know that our decimal is here at the end, and we're going to move it over once and twice, giving me 1.2. So that's going to be 1.2. And then the last one, 1.20%. So 1.20%. I'm going to move it over twice. 1, 2. And that's going to leave me with 0.0120. All right, great. Now that we have our numbers, let's go ahead and write in our place values. So I'm going to go ahead and put my place values in. I like to take it out to the thousands place. Okay, so let's go ahead and compare. obviously we're going from least to greatest. And looking at this, we have one that has a number that is in the whole number position. So we know that that's going to be the biggest number. So we know that that's going to be number 4. But let's look at the other ones. Let's go ahead and compare them. So let me go ahead and pick a different color. Here we go. So let's look at 0, 5, 0, 120, and oh, look at this one. 0, 1, 2, 0. So if we're just looking at the thousands place here, if we're looking at the smallest number, we're really comparing the 12, the 120, and the 50. So I would say that my next least, oh, I'm sorry, that's the greatest. So that my least would be this one right here, followed by my top one, followed by my second one here. Okay, so now that we've put these in order from least to greatest, let's go ahead and let's just take a second and rewrite them. So I'm going to put 1.20%, comma, 1/20th, comma, 0.120, comma, and 120%, comma. And let's go ahead and just write them. I guess I could have written them over here, but let's go ahead and write them in ascending order here. So 1.20%, 1/20, 0.120, and 120%. And we're finished. All right, I've got one more, and this one's just slightly different than the other 3. Shade in all of the numbers that are less than 1/3. Well, first of all, we need to figure out what 1/3 is. So let's go ahead and just take a moment and do that. So 1/3, I'm going to do it down here, is 1 divided by 3. I'm going to go ahead and add my 0, and 3 goes into 10 3 times, leaving me with 9. And I'm just going to go ahead and continue this process. Bring down a 0. And you can see that this process is just going to repeat itself, leaving me with 0.33 repeated. So 1/3 is equivalent to 0.33 repeated. So I want to know which numbers are less than that. So let's go ahead and write these numbers down and figure out which ones are less. So I'm going to go ahead and just write them down over in my little chart here. Let's go ahead and write these numbers down. And then we'll transfer them all. Okay. There are a couple of these that we can automatically select. And you're probably thinking, can I already select the negatives? I know that all negative numbers are less than positive. So you're exactly right. So let's go ahead and automatically just circle -3/7 and -2/3. And we actually don't even need to deal with them because we know that they're less than 1/3. Now, how about the other ones now? Let's go ahead and convert them all into decimals. So 33.33%. Here's what that's going to look like. 33.33%. I'm going to go ahead and convert. So I'm going to move it over, and it's going to be 0.3333. So if I take that number and actually compare it to 0.33, and if I'm looking at the place values, remember, place values meaning I would add zeros, then obviously this number here is not going, 1/3 is not going to be less than this number because I have 3333 and 3300. So that one is not going to work. So I'll go ahead and write that up in here just so we know it. So 0.3333, but that's not going to be an option here. What about 3.421? Well, that one's definitely going to be greater than, right? Because it has that whole number. So we're not going to circle that one either. And we already knew that one was in decimal form. How about 1/6? 1/6 is going to be 1 divided by 6. So 1 divided by 6, I'm going to go ahead and add my zeros and do my long division. Bring my 0 down. And then 40 divided by 6 is going to be, well, it'll go in 6 times, 36, bring down a 4, and it's going to go ahead and continue that process. So it looks like it's going to be 0.166. All right, great. Now, comparing that to 1/3, that's obviously going to be much less. So we're going to go ahead and circle that option. All right, I'm running out of room here. I'm going to go ahead and just erase a couple of things just so I can use this space for the last 3. All right, now let's go ahead and look at 3.75. So 3.75, here we go, percent, 3.75%. I'm going to move that decimal over twice, leaving me with 0.0375. So go ahead and write that over here, 0.0375. And if I were to connect, or if I were to compare that with my 0.3, that is definitely going to be less than due to my place value. I've got another fraction to do. You can see how much work this is. So let's go ahead and divide 2/9. I'm going to go ahead and put my decimal in there. It's going to go in there twice, giving me 18. And then it's going to continue that same process. And I could keep going, but I'm not. It's just going to be 0.22, which of course is less. So I'm going to go ahead and circle that one as well. And the very last one, 0.034, already in decimal form, which is great. And I can see that that is definitely also going to be less than due to my place value. So a lot of work for this one. You can see the only ones that did not work were those 2 that we talked about, 33.33% and 3.421. But all of the other ones seem to have worked, and you can use your chart to kind of help you organize yourself. All right, that brings us to the end of our lesson on ordering and comparing rational numbers.